So what is aviation contrail? When you see an airplane fly in the sky, sometimes you see 2-mile-long contrails, the white clouds coming out of the aircraft. Other times you don't see anything, nothing visible. Why is that? Well, aviation contrails are formed under specific atmospheric conditions. One condition is high humidity. You must have water vapor in the atmosphere. The other condition is low temperature. So these are the conditions. If you look at the physics of contrail formation, as shown here, when you have aerosols like soot, particulate matter from the aircraft engine exhaust, right? Those are nucleation sites. Very short time, you're going to have particles condensed into water droplets, okay? And then the water droplets freeze and become crystals, and the crystal grow. That's what you see on these images, these beautiful mile-long contrails. Starts from the emissions from the aircraft engine. And then if you have enough water vapor in the atmosphere, if it's cold enough, and then ice crystal and subsequently contrail will form. So, contrails, they only represent a visual hallmark of modern aviation, but it has significant impact on the environment. Okay, studies have shown the global warming effect of aviation, at least half of that actually comes from these contrails. Another half comes from the carbon dioxide emissions from burning jet fuels. So in this case, contrails, they're just not a beautiful visual thing. They actually have significant impact on the environment. So you might think, well, how do we reduce the environmental impact of aviation? Which means we should avoid contrails, right? So how do we do that? We can use advanced combustion technologies to reduce particulate soot emission so you don't have those nucleosides for water condensation. Or let's use a new type of fuel, such as sustainable aviation fuel, which lacks of aromatic contents, which will reduce soot emissions. This is actually a very promising aspect of these bio-derived sustainable aviation fuels. Perhaps we should use some new propulsion technologies, hydrogen fuel cell, but hydrogen is completely a different story. We're going to talk about that in future series. Now, from the operation perspective, we know that it must have humidity, it must have low temperature in order to form contrail. Does that mean we should change our altitude? For example, we fly at a lower altitude, 20,000 feet instead of 30, 40,000 feet where the temperature is lower? Yeah, that will certainly help with contrail, but that's not efficient for the aircraft, right? From the total efficiency perspective, with liners okay with spending more fuel on the same route? Or can we operate all aircraft during daytime instead of nighttime? Because the studies have shown the contrails to be more severe during nighttime. So these are all the questions. I don't have a clear answer, but this is a very active research currently going on the topic of sustainable aviation, which is try to understand what are the physics of contrail formation and what are the mitigation strategies.